Hey there, Mr. Sutton here with the IM3 Honors 1-6 Extra Practice Number 1 Solutions on Transformations.
For this problem, I'm doing a whole bunch of transformations on a square root function and trying to figure out where that should end up. So I'll start by doing the parent table for square roots with the points 0, 0, 1, 1, and 4, 2. That's always a good starting point. And now let's take note of the transformations going on up here. This negative 4 outside the function is doing a couple things. The negative is reflecting us vertically. The 4 is stretching us vertically. In sum, we're actually just multiplying by negative 4 on the y values, for that piece of it anyway. Now the plus 3 inside is shifting us to the left 3, opposite of what you expect. The plus 6 is shifting us up 6, so left 3 and up 6 is the rest of it. Let's make a new table now, which incorporates all of that. So the only thing happening to the x values is this left shift of 3. If I'm shifting left 3, that means I'm actually doing x minus 3 for all of those. Now for the y's, we had to multiply by negative 4, and we also had to go up 6, which means we have to add 6. So I'll write negative 4y plus 6. And if we write it this way, we're making sure that we do the reflection and the stretch first before the translation, which is how it should be. All right, let's go through for the x's. So we're subtracting 3 from all my original x values. 0 minus 3 is negative 3. 1 minus 3 is negative 2. 4 minus 3 is 1. Next up, I have to multiply the y values by negative 4 and then add 6. Negative 4 times 0 is 0, plus 6 is 6, so that first one's kind of easy. Negative 4 times 1 is negative 4, plus 6 is 2, and then negative 4 times 2 is negative 8, plus 6 gives us negative 2. Let's put all those together and connect the dots. So we have negative 3, comma 6, which is up here. We have negative 2, comma 2 right there, and 1, comma negative 2 right there. Now the square root function has a starting point, and it goes forever in only one direction. 0, 0 was the original start. That has now transformed into negative 3, comma 6. So this spot right here is where we're going to start, and then we'll go in one direction through the remaining points. To draw this square root function, let me start with my big 3 points for square root functions. The parent points, we've got 0, 0, 1, 1, and 4, 2. Now the transformations that are going on, this 1/2 outside the square root function is going to shrink us vertically, multiply the y values by 1/2, and the minus 4 outside the square root is going to shift us down 4. So let's incorporate those changes into our big 3 points. So rewriting those, all the stuff that's happening is happening to the y values. Y is getting multiplied by half. Down 4, that's a y thing. So all the x's are actually going to say this the same. So I'm just going to repeat all the x values. Now for the y values, we need to do 1/2 times the y, and that has to happen before we shift down 4. So it should be 1/2 y, and then down 4 we're going to do minus 4. Notice that I don't have a parentheses. I want to multiply by 1/2 first and then subtract 4. Transformations always happen after reflections and dilations. All right, so putting my values in the table here, again, all the x values are just being repeated, so 0, 1, and 4. Now for the y values, I'm multiplying by half and subtracting 4. Half of 0 is 0, minus 4 is negative 4. Half of 1 is 0.5, minus 4 is going to be negative 3.5. And then half of 2 is 1, minus 4 gives us negative 3. So graphing these out, we've got 0, negative 4 right here. We have 1, negative 3.5 right about here. And we have all the way over here 4, negative 3. Now, in order to actually draw this, I need to remember that this is a square root function which has an end point and goes forever in only one direction. So my end point is going to be whatever 0, 0 turned into. That was 0, negative 4. So I'm going to start at 0, negative 4, and then I'll draw my arrow going like this for the rest of the square root. To draw the absolute value function given here, let me start with my big 3 absolute value parent points, negative 1, 1, 0, 0, and 1, 1. And I'll just transform those 3 points. The transformations going on here, the negative outside the absolute value gives us a vertical reflection over the x-axis, and the negative 1 outside means we're shifting down 1, subtracting 1 from the y values. So incorporating a vertical flip and shifting down 1 into my table of values, this is all happening to y values, so the x is just going to stay the same. I'm just going to rewrite x here. But for the y values, now if I'm reflecting vertically, I'm multiplying all the y values by negative 1, so I need a negative y, and then shifting down 1 means I have to subtract 1. So negative y minus 1. So for the x's, again, those all stay the same. Negative 1, 0, and 1, just basically cutting and pasting from the original. But now the y values, we have to negate and then subtract 1. So this becomes negative 1 minus 1, so negative 2. This is negative 0 minus 1, so just negative 1. And this is going to be negative 1 minus 1 again, so that's also negative 2. Graphing these out, we've got a negative 1 comma negative 2 down here, 0 negative 1, and finally 1 comma negative 2. And I'll just draw my absolute value accordingly, and there we are. To graph this square root function, I'm going to start with my parent table. So my 3 points I'm using, 0, 0, 1, 1, and 4, 2. And now the transformation's going on. This minus 3 inside the function means we're shifting right 3. It's always opposite from what you expect inside. The 2 outside the square root function means we're actually stretching vertically, so multiplying the y values by 2. So incorporating my vertical stretch and my right shift here, if I'm shifting right 3, that means I'm actually adding 3 to the x values, so I'll make sure I do that. And then we're multiplying y by 2 to stretch this, so 2y. Let me change the x values from the parent table now. So we have 0 plus 3 is 3, 1 plus 3 is 4, and 4 plus 3 is 7. Now to do the same with the y values, 2 times 0 is still 0, 2 times 1 is 2, and 2 times 2 is 4. Graphing those 3 points out, we've got 3 comma 0, 4 comma 2, and then this is 7 comma 4 right here. Now, as far as where the square root starts, 0, 0 transformed into 3, 0. So this point right here, this is the end point of my new square root function. So I'll start here and go through the other points in one direction. For this problem, I'm trying to graph this absolute value function. I'll start with my parent table with my 3 points, negative 1, 1, 0, 0, and 1, 1 for the parent absolute value function. And now for the transformations happening, the 2 outside the absolute value means we're stretching vertically, multiplying y values by 2. The plus 1 inside means we're shifting to the left 1. So that's always opposite from what we expect inside the function. So let's incorporate these now in a table of my new 3 points. We said we were shifting left 1, so that means I have to do x minus 1 to get the new x values. And then we're multiplying y by 2 to stretch vertically, so 2y. All right, subtracting 1 from all my x values. Negative 1 minus 1 is negative 2. 0 minus 1 is negative 1. And then 1 minus 1 is 0. Now we're doing 2 times the y values. So that gives us 2 times 1 is 2. 2 times 0 is 0. 2 times 1 is 2. Graphing these points out, we've got negative 2, 2. That's going to be right about here. And then we have negative 1, 0 right here. And then finally 0, comma 2. And let's just graph the absolute value using those 3 points. To graph this square root function, I'll start with my parent table with the points 0, 0, 1, 1, and 4, 2 for square root functions. And for my transformations, the 2 inside the square root function, the times 2, means that we're actually going to be shrinking this graph horizontally, multiplying my x values by 1/2, dividing by 2. And then the plus 4 outside means we're shifting up by 4. All right, so let's go ahead now and incorporate that in our new table. So if I'm multiplying x's by 1/2, I'm going to write 1/2 x here just to remind myself. And shifting up 4 means we're adding 4 to the y values. So if I'm taking half of all the x values, half of 0 is still 0, half of 1 is 0.5 or 1/2, and then half of 4 is 2. Adding 4 to all the y values, we've got 0 plus 4 is 4, 1 plus 4 is 5, and 2 plus 4 is 6. Graphing those out now, 0, 4, that's right here. And because that's where 0, 0 got transformed to, this is going to be the new endpoint for my square root function. I'm going to start here. Now I've also got the points 0.5, 5 right about here, and 2, 6 right up here. So starting at my new 0, 0 spot, going through there in one direction, there's my new square root. To graph this square root function, I need to write the parent table and then do some transformations. So my parent table for square roots is 0, 0, 1, 1, and 4, 2. Those are my big 3 points that I always use. For my transformations, got a lot going on here. We have this x plus 1 inside, which means we are shifting left 1. This 2 outside means we're stretching vertically, and the minus 4 outside means that we are shifting down 4. And this vertical stretch is multiplying all the y values by what it looks like, by 2 here. So to recap all of those things going on, we have a stretch vertically, multiply y by 2. We have a left shift of 1. We have a down shift of 4. Let's put all that now in our new table. So the only thing happening to the x's is this left shift of 1. So we can write x minus 1 to reflect that. And then we're shifting vertically or stretching vertically and shifting vertically. So we're going to do 2y for the stretch, and then we'll do minus 4 for the shift. All right, let's incorporate all that now. So we've got all the x values minus 1. 0 minus 1 is negative 1. 1 minus 1 is 0. 4 minus 1 is 3. This next one's a little bit more mental work. We're going to be doing 2 times the y value for the stretch and then subtracting 4 for the shift. So we have 2 times 0, which is still 0, minus 4 gives us negative 4. 2 times 1 is 2, minus 4 gives us negative 2. 2 times 2 is 4, minus 4 gives us 0. And let's graph these and hope for the best here. So we've got negative 1, negative 4 for that first part, and then 0, negative 2, and then 3, 0. Now to figure out where this thing starts, because we do have a starting point for square roots, 0, 0 was the original start. Now that is negative 1, negative 4 that got transformed to. So we'll start at negative 1, negative 4, and draw one direction going out from there. For this multiple choice question, we have a triangle PQR, and they're telling us that this was translated 4 units up and then reflected over the y-axis to make a new triangle, P prime, Q prime, R prime. We want to know which diagram actually represents all that. So I think the easiest way to do it, I mean, if you notice the triangle, the original triangle in each of these graphs, PQR, it's in the same place, same orientation. So really, you just have to figure out what the new points of PQR look like, and then figure out which one of those prime triangles actually matches it. I'm going to start with just one point. We'll start with point P. So we're translating 4 units up, which would bring us right up here, and then we're reflecting that over the y-axis, which would flip us over to here. So this spot right here at 2, 4 should be the location of P prime. Now I could keep going with the other points, but they're, let's see how many graphs actually have a P prime in the right place, and then if we have to figure out what the other ones transform into, we will. So clearly choice A does not work because their P prime is all the way down here when it should be up here. Now let's do choice B. So up 4 and flip, and the P prime in that graph is in the correct place. Let's check out the other answer choices, and then we'll come back to B if we have to narrow things down further. Down for C here, up 4, flip. P prime is nowhere near the P prime that they gave us in that one, so C can't be the answer. And in choice D, up 4, flip, not too far away, but still not the same point. So we can actually eliminate A, C, and D using just a single point that we transformed from the original graph. So it could only be point B, or answer choice B. Now, if you do double check, if we go up 4 and then reflect Q, we get Q prime. If we start with R, it would go up 4 and reflect that, we get R prime. So it actually does work out with choice B. For this one, we have the point 4, 8, and it's reflected over the x-axis. We want to know the coordinates of the image, so basically the new point for P. So if you're going over the x-axis, that is a vertical flip. So that means that the y value is going to be changing sign, which means that instead of 4, positive 8, we will now have 4, negative 8. And if you understand that, then you're very quickly able to pick answer choice C.